So what I'm going to do now is I'm going to transform these features into where they're strings into numbers, and then I'm also going to create our train test split, and then I'm going to train our model. At last, what's going to happen is I'm going to output an evaluation report that's going to give me the accuracy of the model. And it's going to be a lot different than how we evaluated the regression model. And so once we get the report, I'm going to step through exactly what that report means in another video and review it, because classification models are a little bit different than regression models. And so first, I'm going to create my train test split. I'm going to have 75% being my train set and then 25% being my test set. I'm doing two things differently. I'm doing a 75-25 split, and I'm also using scikit-learn to split the data set. 75-25 is just fine. Truth be told, you just have to find something that's good for your use case. And sklearn is a great package for doing it so that we don't have to write all that code that splits the data set on, that splits the data set. It'll just do it for us. So I'm going to split it into train and test set. And now I'm going to change up a little bit of this. And so I want to take first what I want to do is I want to take this credit amount section right here that shows like how big the loan is. And then I'm going to use this code right here to split it into 3 quantiles. And these are going to be some equally sized sets. So it's going to split it up into the lowest 1/3, the mid 1/3, and then the highest 1/3. And in the next cell, what I'm going to do, and you can see how credit amount bin is the column name, is a lot different. I'm using the PDQ cut method, if you haven't seen that in pandas, but it's very useful. And here, what I'm going to do is I'm going to see how the good and bad credit risk changes by the credit amount bin. And so how I can do that is I can group by credit amount bin into the low, middle, and high credit amounts and take the average. And the average is going to give me what percentage of each of these bins has good credit risk. And so if I do like this, I'll get that answer right there. And as you can see, the lowest credit amount bin has about 70% as good credit risk. The mid has 75% as the highest. But on the higher end, the higher bucket has 62 or 63% as good credit risk. So there's a lower presence of good credit risk in that higher end bucket, and I'm thinking that that's useful for our model. And so I'm going to do the same thing to our test set. So we have the credit amount bin in the test set. And here I'm importing a lot of stuff from sklearn to be able to not only transform the data set, but also to import our logistic regression model and the classification report that I'm going to explain in the next video. So these are all the features here that were categorical. Either they were left as strings, like some of these, like checking status and saving status, or they were binned, to where they were, still left as numbers, but they're a single column. And so it really helps us when we're fitting our logistic regression model to not leave the data set as just these categorical variables being a single column, but to create what are called dummy variables. And what that's going to do is it's going to have 3 columns. It's going to transform the data set where it has 3 columns now. So it's going to be credit amount bin 0, credit amount bin 1, credit amount bin 2 to be associated with each one of the categories. And in each one of those columns, it's either going to be a 0 or 1, whether that's the actual bin number. So it's just going to transform these. It's going to transform this into 3 columns, and each column is going to be 0 or 1. And your logistic regression model is going to learn a parameter on each of those columns that's going to be, what it learns to be the linear relationship between that feature and the class label, which is just a 0 or 1 label. And so if credit amount bin 2 has a lower good credit risk presence, it should learn a negative coefficient, saying that if this person is in bin 2, we should drop the probability of them being good credit risk by giving them a negative coefficient on that feature. So how am I transforming it? I'm saying that these are our categorical features. I'm importing a column transformer module from sklearn, and what it's going to do is it's going to one-hot code. So it's commonly called one-hot encoding because you only have zeros or ones in the vectors, and it's going to one-hot encode all of them. So you can say one-hot encoding or dummy variables. It's the same principle. And so what I'm going to do is I'm going to create this pipeline that's going to take in this preprocessor, which is going to one-hot encode those categorical variables. And then what it's going to do is it's going to pass the output of that, this transformed data set, into my logistic regression model. And you can see I've set the random state and the max number of iterations. And then it's going to fit that logistic regression model to that data set. And then it's going to produce some predictions on the train and test set, and then evaluate the accuracy for it. And so I'm generating this classification report, which I'll explain in the next video. But as you can see on the training accuracy, we got 74% roughly. And then on the test accuracy, we got 76%. We can do better than this, but this isn't too bad. We'll see how we can change this once we've evaluated this classification report. And we'll see how fitting other models may improve it. And so, let's take a look at this classification report in depth.